know what it's about. It's kind of a weird thing, so it might be a new thing. By separating the variables, so by separating dp and dt, find p in terms of t. So make p the subject. So what you could do is, well, what would dp be equal to? dt. So go on, what was your next you're thinking was bringing over to 0.1, was it? Okay, so what would you do next? I mean, in terms of t. Yeah. Yeah, that's what you. So the problem with, yeah, you could do it that way. It might be simpler to bring just the p over. So leave that as 0.1 dt. Bring just the p over, and then in terms of polynomial form, you could write it as, well, we could write it as 1 over p as a coefficient. And then, like you said, if you integrate both sides, what would you then get? Yeah. Yeah. And you're aiming towards getting p equals. Yeah. Yeah. Ah, okay. Yeah, I think that's it. Any questions there? Let me just see if I have the. And they wanted us to do. We have to sub it into something. dp. So ln magnitude p is 0.1 t plus c. Oh, I see. Sorry. Is this plus c? So then, yeah. And then there's a little thing that they do, because we don't know what the plus c is, and it's kind of, it's not really, it doesn't really make sense to do anything with it, because we have no chance of knowing what it is. This power plus another power, you could work backwards to make it one thing times another thing, like e to this times e to that. E to the power of c is kind of meaningless, because c, we have no idea what it is anyway. So we could just call this e to the power of c. We could just call that c, because that's just a number. But for the sake of clarity, they give it a different name, and they just call it a, usually a capital A. And because it's a number, it goes in front. So they just say, a, and then e.01 t. And so, yeah, if you have two things plus, you can just separate them out. And if you've got something to do with c, it would be like if we multiplied both sides by 2 and you had 2c, you would just call that a, and just go from there, because it's not, yeah, because c just comes, because we've no way of knowing it. Okay, any questions about that? And I suppose the big thing as well is this bit here. You basically, if you've got dp on one side and dt on the other, get all the p's on one side, get all the t's on the other, and just integrate both sides. The difference was there was no t's, and so it was just the number. Where was I? Yep. Yes, so the equation we got is the general solution, and now we're going to find the particular solution, which is when you actually find what number a is. So this is like in integration when you find what c is. That's the particular solution. Any idea how we can use this information? When t equals 0, p is 200, and we have to say what a is. Yep. Yep. And so what would p be equal to then? The particular solution? That's it. And what that shows you is that when t is 0, basically this a is always the starting population when time is 0. Yeah, so yep, any questions there? Okay, and so kind of from now on you could see when time is 0, p is 200, and so the coefficient is 200, or the other way around. Yeah, this just says what you do, rearranging the left side, rearranging the right side, integrating both sides. Okay, let's try this one. Tell me if any of that is cut off. Okay. It is. We're just actually checking our answer by differentiating it to see if we get what we started with. Well, you have to find dp dt, and so if you have ln p, that might be more difficult. So I'd literally just go dp dt. Yeah. Anything you notice there? Yep. Yeah. So fairly straightforward. Yeah, any questions there? Okay, so first we integrated it to get the population growth in terms of time, and then we just did a little differentiation to check our answer. Okay, this is a new one. Let's try this. Mm-hmm. Yeah. Yeah. Okay. Yeah. Mm-hmm. Yeah. Mm-hmm. Mm-hmm. So 5, 10t plus a to the minus a half. Looks like it. Yeah. Yeah. So 5 over p. Okay. And then how about part C? Okay. Okay. And do you have a calculator? All right. Okay. Oh, there you go. 12. Find the value of p. So p equals 12. Let's take a look. So part A, 10t plus a. Then we did that. That was B. Part C, A equals 36. And then D, it's 12. Yeah. Okay. Any questions about anything there? Yeah. Okay. Let's try this one. Now I've got squared. Mm-hmm. Okay. No, that's only if it's 1 over p. So think about this as like p to the minus 2. P to the minus 2. What do you do? Let's see. With integrating, you add 1 and then divide by the new one, don't you? Oh, no, no. Yeah, you add 1 and then divide by the new one. Yeah. And that, yeah. Mm-hmm. Yeah, so we can just reciprocate those two, bring the minus to the other side, and then it's just 1 over all of that. And that's what they wanted? Yep. Okay. Part B. Mm-hmm. Yep. I would sub C in first. Right. What does it look like they did to the top? Yeah, I believe they times it by minus 100, but to the top and bottom. They did that to get. They did that just to get rid of the decimals, so there was whole numbers. Or, yeah, okay, maybe 100 instead of minus 100, and then they just swap them around. Whatever. Yeah, so that's going to be minus 100 over t minus 10. Yeah, 100 over 10, which is 100 over 10 minus t. Basically, they just incorporated this minus down into the bottom. So instead of having two minuses, they have just one minus, which is considered simpler. Okay, any questions there? And then C, what happens to P as T gets closer and closer to 10? What do the yeah. Why is that? Yeah, that's it. That's it. Basically, it's gonna increase, and then it's like approaching infinity, basically. Okay, any questions there? Okay. Let's try this one. Yeah. Yeah, they've integrated y with respect to x, basically. Mm-hmm. You don't need to bring the 3 as well, I don't think. It's up to you. Okay. Yeah. Mm-hmm. 3x plus c. That's it. Any questions there? Okay. Let's try this one. The okay. Something's missing. Yeah. Mod. Yeah. And I know you don't always need the mod, but if you don't use it every time, one of these days you just forget about it when you need it. Mm-hmm. Okay. Okay. Yeah. Yeah. So then that's A. So A. And that's y equals, I think that's what we were asked for. A e to the x squared minus 4. Yeah. Any questions there? Okay. That's that. Okay. So now this is more like it. Let's try this. Not necessarily. Well, it's how would you say something is like y equals or y is proportional to if it's the square root? The square root of the depth. Yeah. Okay. And then, so in this case, so with y we'd use x. Let's just use h for this one. So y is proportional to the square root of h. What would be y equal to in terms of proportion? Like if you think back to GCSE, y, I don't know how it was done. Basically, y is proportional to root x. That tells you y equals, how would you express that? You may not remember it. It's basically root x times k, the constant of proportionality. And so how would you express this one then? No. K root H. So let's take a look. Water tank is filled in such a way that the rate at which the water is proportional to the square root of the depth. So it has to be, let's see, it's filled this way. The rate at which the depth of the water is proportional to the square root of the depth. I think that has to be K root H, doesn't it? K root H. Initially the depth is 4. Okay, so how would you show that? I think it has to be plus 4, yeah. Okay. Maybe I'll just check that before we go any further. dH by dt is equal to K root H. No, I was right. It's because we haven't connected the two. Yeah. We have to write H in terms of T is equal to K root H. Okay, so now using our splitting the variables method, how would we get an equation for H in terms of T? Yeah. 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 And K is just a number, just a constant. Just same as you usually would. Yeah. Bidmus, the index is connected only to the H. Yeah. That's it. Yeah. Mm-hmm. Mm-hmm. Nope. Show that root H is equal to a half KT plus. Oh, I see what you're saying. Oh yeah. Well, if the initial depth, remember we had the plus 4. Yeah. So basically, at time 0. So at time, what is root H? Let me think about this. H is 4. Other way around. Yeah, so basically it's root 4 equals. Yep. Yep. So C equals. Okay, and so what is root H equal to with a particular solution now that we know C? Yeah, that's it. So, well, they said show that, and so we showed that. And yeah, it's not always plus. Sometimes it's times, so there's a bit more to it. But yeah, we showed that. Okay. Okay, what's next? Yeah. Equal to 3k plus 2. Okay. Yeah. 2 over 3. Okay. Okay. Mm-hmm. What would that be? 2/3 times. Okay, 2/3 times a half. Yeah. Mm-hmm. Yeah. Equals 12. Okay. Any questions about anything there? And I think the big picture thing is, what were we thinking at the start? That it's just, where's the very beginning of this? B4. I deleted it. I think, oh no, this is a different one, is it? Yeah. That one, that one. Yeah, it's basically, if it's proportional, then the HDT equals K root H, and you have to do it this way so that we can get some kind of H equals in terms of T. So connecting H and K. If we did it the way we were doing it before, we don't get a connection between them, because like when time is 0, T is 0, and so there's no there's no T. We can't use it for anything. Okay, so that's the differential thing. So that matches up with exponential growth. Let me just check the this thing here. Forming differential equations from rates of change, and then solving differential equations. So that's what we were doing. And I think exponential growth comes before then. And so I think you'll be okay with exponential growth. So it's basically find the value of t for p is this. So that's just subbing in and solving, which I think you're okay for. Yeah. What happens is this gets larger. Pt exponential decay. Yeah, I think you're gonna be okay there. Yeah. Given that y is equal to this, find the value of t. So you're just subbing in t equals 0. I suppose what is y equal to when t approaches infinity for this one? So b. Yeah, y equals 40, and that's because it has a negative exponent, negative power, so it's going to be 10 over. Yeah. Do you want to sketch the graph? I think you're okay for that stuff. By consider what happens, find the value of c. We'll try this one. Yeah, let's try this one. Yeah. As t approaches infinity, you're thinking of when t is equal to 0. Yeah. Okay. Yeah. Yeah. How did you get 45? What does the big T temperature, the big T stand for? Is used to model. Yeah. So the temperature is big T not 35? Okay. I was just making sure. Okay. Minus 10b. Yep. And then hence. Yeah. Yeah. 0.25 equals b, and whatever that is, the 3 sig fig, and then d. Correct. This would be like saying find the gradient of the line when x equals 35. Correct. Yeah. 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 Oh, hold on. We better get that b now. Minus 0.1 ln 0.25. Okay, so that's 0.139. So let's do this properly. And so it was t equals 20 plus 60 e to the, I think it was minus, Was it minus? Yeah. Minus, and b was 0.139 t, and so we're finding dt by dt. Okay. Yeah. Mm-hmm. T was 10 for that one, was it? Where did we have that one? Oh, that was given to us in the 10 minutes. Okay, so t equals 10. That's it. Why is our answer negative for this one? Yeah, because the rate is decreasing, so it'll be negative. So that's alpha e to the power of minus that answer 0.139 thing times 10. Hopefully that's all fine. So the rate is, so we did, let's say minus, yeah, let's say it's minus 2 degrees whatever per minute. Yep. Okay, 60, 0.139, and then minus 2.079 per minute. Yeah, any questions there? Okay, so I think P is the ST. What happens if the population gets larger? Okay, so this is just population growth stuff. Further exponential functions, ln. Yeah. We looked at this before. The derivative of a to the x is ln a times a to the x. That's all that the whole thing is about. This is all just exponentials, I think. I find the value of dv dt, so that's differentiation in terms of that stuff. I'm just making sure there's nothing that, because I think if we, you did that previous question, so I don't think there's anything particularly new. Okay, let's take a look. So exam questions. So solve the differential equation. Wow, 8 marks. Okay, so there's that one, and you've got this long question 2. Show the depth. How's this thing? Okay, find y in terms of x and all this. Oh, hang on. Okay, well, we'll start with 4 marks and we'll work our way up. Okay, so how about this one? Mm-hmm. Mm-hmm. cubed, and they said something about here. Mm-hmm. Yep, a equals 1 over e, and so we were asked to find y in terms of x. X cubed, and I think that's it, because this has an exponent, like it has a power, so there's nothing you can do there. Find y in terms of x. Let's just make sure. So we said when that's 1, that's e to the 1. That's it. Yep, it's a bit awkward, but that's it. Okay, any questions there? Okay, let's try this 8 mark thing. So basically y equals in terms of x. Mm-hmm. Mm-hmm. Oops. Yeah. Yeah, so this is kind of like, oh, there's a much easier way to do it. Expand the brackets. And it could be like that, I don't know, or whichever way you want to express it. Let's say 1 over x squared plus x. How did you do the left side? Right? No. Can't do that. I suppose you could do it as two things multiplied. 1 over x times 1 over x plus 1. Yes, that would work. Do you know how you would do that? So that there, how would you do that? Well, Mm-hmm. Yeah. Ln x plus 1. Let's just see. What might be easier is if we swap them around. So can you see kind of that we first we integrated 1 over x plus 1. Now we're having to integrate this, which is kind of a harder thing to integrate. Yeah, that might be easier. So this one, yes, that'll work. The other thing that I believe will work is if we were to swap them around. So basically we said the harder of the two is u and the easier of the two is dv dx. That way you're integrating the easier one and you're doing it that way. But yeah, partial fractions is probably the easiest way because it's just two fractions. Yeah, so and then you get ln y. So ln y is equal to that. And then how would you go about getting y equals? Yeah, you do e to the power of it and just the usual way. Let's see. What number was that one? So that was 2. Mark scheme. I think that was the very first one, was it? Yeah, they did it using partial fractions. Yeah. I just want to see if there was anything more difficult about it. X equals 1, so they just subbed those in. No, it looked like it was pretty much the same as what we were doing before, except the integration was harder. And I just want to see what these exam questions look like. So that one, and then there's these kind of long ones. Find v in terms of t. So we did that exponential. What is this? Yes, so what would be for part 2 for this one? Mm-hmm. Yeah, so that's just putting it into kind of real life terms. Chopin's a parachute, her speed is modeled by this. I'll express this in partial fractions, so they're using partial fractions. Use this result. Yeah, so they're very similar to what we were doing. Just trying to see. Okay, sometimes they involve trig, so it involves integrating trig, but it's the same idea by the looks of all of them. Yeah. So I think it's okay there. So this is just going to take practice for all of these. Yeah, how did you find that, Edward? Yeah. Well, yeah, differential equations is one of the hardest ones because I believe it's the last chapter in the Core 4 MEI book.